Hi, Dana Edge. I want to make sure that everybody understands the different situations under which we use the different counting formulas. A lot of times you can do this intuitively, and the intuitiveness helps determine which of the counting formulas to use, but you also need some guidelines to go by. So let's take a look. When we look at the multiplication rule, this is going to be used by counting the number of positions and the number of ways to fill each position. This is going to be a case of where we do it with replacement. In that the way one position is filled has no effect on the way the next position might be filled. This can also include, for example, suppose we're looking for a total number of possible combinations for a pin. You know, a pin on your debit card would normally have 4 numbers. Each of these numbers could be anything from 0 through 9. So there's 10 possibilities per position. So there are 10 different things that could go here, 0 through 9. There are 10 different things that could go here because choosing a digit to go in the first position has no effect. It could be used again, so that's with replacement. Also, that's possible repetition. There are 10 that could go here. There are 10 that could go here. And the multiplication rule says that therefore there are 10 times 10 times 10 times 10 possible combinations, which would be a total of 10,000 possibilities. Now, if you look at this as a number, for instance, say your pin is 2653. So you've got a 2 and then a 6 and then a 5 and a 3. You can also look at this as the number 2,653. So if we assume that you could use 0, 0, 0, 0 and 9, 9, 9, 9 and everything in between, the number of numbers from 0 through 9,999 is actually 10,000 possible numbers. 1 through 9999 would be 9,999, but if we include 0 as a possibility, that is 10,000 possible numbers. So these two things should relate to each other. What about the factorial rule? Now remember that the notation for doing a factorial is the exclamation point. So 9 exclamation means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but there's no point in putting the times 1. The factorial rule works the same way, except there's no replacement. No repetition. You can't use the same thing twice. For instance, if you're lining people up for a picture, let's say you've got 4 people. We're going to take a picture of all 4 of these people so that we're going to line them up side by side. So there are 4 people that could go in the first spot. Once you choose somebody to stand on the left, there are only 3 people that could stand next to him, 2 people that could stand next to her, and that sets 1 person at the end. Once you've put the first 3 in, that's a done deal. So this is 4 factorial. 4 times 3 times 2 times 1. So there's a possibility of 24 possible ways to do this. That is considerably smaller than 4 times 4 times 4 times 4 would be. Permutations and factorials are related, except that with a factorial, we automatically go all the way to the end. With a permutation, let's say we had 10 people and we're going to choose 3 of them. So with a factorial, it would be 10 times 9 times 8 times 7 times 6 all the way down. If we're only going to choose 3 of them, so we've got 3 people that we're going to line up. Maybe we've got 10 people in a committee and we're going to choose 1 to be the president, 1 to be the treasurer, and 1 to be the secretary. So there is a possibility of 10 people that could be president. But they can't be both the president and the secretary. So now there's only 9 people to choose a secretary. And having chosen those 2, there's only 8 people left that could be the treasurer. So this is actually going to be 9 times 8 times, 10 times 9 times 8, which would be 720. Now the formula to do this, instead of having to reason it out like this, the formula for a permutation, and they can write it as NPR, or you can write P NR. You're going to have a button on your calculator. Or if you've got like a graphing calculator, this may be hidden in a menu somewhere. So you find the menu with the statistical functions. But for a typical calculator like this, there's actually a key. Well, this one actually has this notation. It could be either. So you notice right here, by the 9, above the 9, the formula to find the permutation of choosing R objects out of a group of 10 is that it's going to be n factorial divided by n minus r factorial, not r factorial, n minus r factorial. Notice that if I did this, if I said I'm going to do the probability of 10 people choose 3, That's going to give me 10 factorial divided by 10 minus 3 factorial, which is going to be 10 times 9 times 8. Should have chosen smaller numbers, shouldn't I? 7, 6, 5, 4, 3, 2. Divided by, this is going to be 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2. Notice that this part and this part simply cancel. And lo and behold, I've got 10 times 9 times 8. So if you're doing it by hand, you might want to do it this way. If you're using the calculator, instead, you put in the 10, pull up the function for figuring the permutation. So you hit the button for NPR. And in my case, I have to actually hit the second function. This is the TI-30. I hit the second function and then the 9 because it's above the 9. Second function key works just like a shift key. And then I hit the 3 and then I hit the equals. 720.